Hey YouTube, welcome back. Today we continue our series in design a chat system. Um, Today we'll talk about today we're still in the proposal level in the high level design. I guess maybe we have three more videos. Yeah. No, we have one video more. One video. This video, I guess, and another that we have another video to talk about the data models. And after that, we start to go into the deep dive step. So today we'll talk about the storage. So let's just keep it fast and talk directly about the storage. It's important to say if you didn't watch the previous. Oh, there is something wrong with my iPad, my trackpad. Sometimes it acts like crazy. Yeah, okay, it's working. So what I was saying, if you didn't watch the previous videos, I hope that you watch them because it's quite important. You'll understand what's going on. If you don't want to watch them anyway, you can just continue because we designed the videos in such a way that you will have the ability to understand each video, even though if you didn't watch the previous. If you watch the previous, this will help you better, but if you didn't watch it, it still works because every video is independent from the other videos, some sort of independent. So today we'll talk about the storage in our system. So we have this system right now. So at this point we have servers ready and services up running and third-party integration. We have like a complete integration. So we have a complete application. So deep down the technical stack in the data layer, this one, we will talk specifically about the data layer. Data layer usually requires some efforts to get it correct. An important decision we must make is to decide on the right type of the database to use SQL or NoSQL. So let's just stop here for a minute. What is SQL and what is NoSQL? So let's just start with a SQL. So a SQL database, it's a structured query language database. This is what it's short for. It's a type of database system that employs the SQL language for managing and manipulating structured data. SQL databases are relational databases, which means they store data in tables with predefined relationships between them. These databases are widely used for various applications, ranging from small scale projects to large enterprise systems. So let's just talk about the characteristics. Sorry, my English maybe sometimes it's not that good. Sorry for that. Characteristics. So let's talk about some characteristics. For example, we have table and schemas. We have data integration, single language, ACID properties. This is quite important when we'll ask you about what is an ACID properties. A SQL database follow the ACID properties. It's called atomicity. It's transactions or in or out or nothing. Consistency, ensuring data remains consistent. Isolation, transactions are isolated from each other. And durability, committed data is saved permanently. We have something called normalization for the SQL database. SQL database use normalization technique to organize data efficiently, reducing data redundancy and manipulating data integrity. We have indexes. Indexes are used to speed up retrieval by creating a structured mechanism for fast data lookup. We have concurrency control also. SQL database manage concurrent access to data by implementing mechanisms like locks and transaction isolating levels. We have transactions, we have backup and recovery, we have replication and clustering, and we will talk in a bit about what replication is important. Also, we can use MySQL, we have Postgres, we have Microsoft SQL Server also. So this is in the SQL. What is a NoSQL? So a NoSQL database is not only SQL database. It's not means we're not SQL at all. لا, it's not only SQL. Okay, it's a type of database system that provides non-relational way to store and manage data. Unlike traditional SQL databases, NoSQL databases do not rely on fixed schema and can handle a variety of data types, including structured, semi-structured, and unstructured data. NoSQL databases are designed to be highly scalable, flexible, and well suited for modern application with complex and dynamic data models. So what is the characteristics? So like I will say more than one time, so just my tongue will use to it. Characteristics. Okay, so we have the first one. The schema is flexible, so NoSQL databases allow developers to store data without need to define a rigid schema upfront. We have data models. NoSQL database supports various data models, includes document based, key value, column family, and graphs. We have scalability. This is one of the most important things. NoSQL databases are designed to scale horizontally, and I will talk in a bit what is scale horizontally is, meaning that you can add more servers to handle increased load. This particularly useful for applications with rapidly growing data volumes. We have high performance. So NoSQL database often offer high read and write performance due to their simplified data models. We have big data and unstructured data. We have replication and availability. We have eventually consistency. This is where the NoSQL sucks, because they don't have the asset transaction. They don't have the asset properties. Sorry, not transaction. They have multiple types. We have document databases, we have key value stores, we have key family stores, and also we have graphs. So the question is when to use this and when to use this. So the decision to use SQL databases or NoSQL databases depends on various factors related to your application's requirements, data model, scalability needs, and development teams' familiarity. So let's just talk about some guidelines that we should follow. So we use SQL database when we have structured data. If your application deals with structured data that fits well into tabular formats like traditional rows and columns, and SQL database is good fit. Example, financial data, inventory systems, e-commerce platforms. Asset transactions. If your application requires strict asset automaticity, consistency, isolation, and durability complaints, such as in financial system, healthcare, and online banking, and SQL database provide robust transaction support. We have complex queries. If your application needs complex queries involving multiple tables and relationships, SQL database Excel is Excel in this area. We have data integrity. If maintaining data integrity and enforcing strict constraints such as foreign keys are crucial, SQL database is good for that. We have consistency over availability. If your application prioritizes immediate data consistency over high availability, and can't relate some performance trade offs, SQL database are better choice. We have small to medium sized data. SQL database are suitable for applications with moderated data volumes. Okay, so when to use NoSQL? So first of all, we have dynamic and unstructured data. If our application deals with unstructured or semi data like social media posts, sensor data, or user generated content like posts or like chat. We have scalability and high volume. If your application expects a rapid growth, needs to handle a high volume of data traffic. This is one of the most important things. We have a flexible schema. If your application's data model involving or uncertain is involving or uncertain, NoSQL database offer flexibility. Over to that, we have intensive applications. If your application is heavy read oriented, like content delivery networks, caching layers, and real-time analytics. If we have maybe you have availability and partition tolerance. If your application prioritizes availability and fault tolerance over immediate consistency, NoSQL databases that implement eventual consistency are suitable for that. Graph and relationship data. If your application involves complex relationship between data points like social networks or recommendation engines. And yeah, developer familiarity. If your development team is more comfortable with NoSQL database, this is one is the so this is a NoSQL and this is a SQL, and this is why we can use both of them and why you would take one of them. So let's just go back to our system and let's just go to this key store. So we have two types that exist in our chat system. We have the let me just try to take my pen, because I guess I will try to use the pen a lot. So I guess we have the first thing. We have the user. Oh, it's so thick. A minute. I want something not that thick. Give me. Okay, this is good. This is good. We have user generated data. Okay. And let's just talk about that. And we have the second thing. We have the actual chat data. So in the user generated data, such as user profile settings, user friends. So let's just do this like that. Like we have like profile. We have friends. What else that we can think about? Profile. Maybe settings also. I guess we could have some settings. So for this, these data are stored in robust and reliable relation databases. We can use them and store them in robust and relation databases. And why we use that? First of all, it's a structured data. It's we know what is a user look like. We know the friends and we know all the settings, and we don't have the data volume are not huge, and it's important for us to have the consistency. And to have like right now we have the consistency, but we want to make sure that we are available, so we could use replication and sharding. Our common techniques to satisfy availability. So what is replication and sharding? So let's just talk about the replication first. So replication in a context of database refers to the process of copying data from one database to called the source to another database called target. So let's just say that we have this database and the database have some data, and so we just copy this data to other databases to make sure that we have in the other databases. Replication is commonly used to achieve various goals, include high availability, disaster. Sorry, not disaster. It's also we have disaster recovery. Let's say that if these databases have been falling, we just get a recovery from or backup from all of these databases. It's good in scaling and read operations and distribute data across different locations. It's good in giving us high availability, disaster recovery, replicating data into remote location provides a disaster recovery solution. We have also it's a good for the load balancing and scaling. It's good for geographic distribution, and we have a lot of types of replication. We have something called master slave replications, or let's only talk about the master slave. So let's assume this is the master, and this master will serve the right operations, and all the and the master is copying all of this. Let's just can I delete, yeah, and the master is copying all of its content to the slaves. These are the slaves, and the master right now, when the master supports the write volume and the slave supports the read volume, when the master have been fall down, one of the databases will be the new master and the other will be the slaves, and it will continue like that. When the master come back, the master could be the master again, and the slave will be slave again, and just to copy the data back, or the master will and this one will retain the master. It depends on the requirements of the how we want the application to work. The second thing is called the sharding, and sharding is database design and partitioning technique used to horizontally partition large databases into more manageable parts called shards. Each shard is essentially separated database that contains a subset of the data. Sharding is primarily used to address scalability challenges in systems where a single database instance becomes an inadequate to handle increasing. So how the sharding process is happening. So let's assume that let me just clear all of that. Okay. Thank you. So, first of all, I have something called a data segmentation. The first step in sharding is to determine how to divide your data into logical segments, often based on certain criteria like user ID, geographic region, or product category. So let's just that we have this data, and basically what we will do is that we will cut this data into pieces. Okay, let's assume that we have shard creation. The first step that we will just try to assume how we will shard based on. So let's, for example, that we shard on user ID, for example. And shard creation, each segment is assigned to separated shard. Each shard is an independent database instance capable of storing its subset of data. So this big database will just be into 3 different databases, and each one has its independent and just work as data by itself. The last thing, we have distribution and replication. Shards are distributed across different physical servers and clusters. Replication might be applied to each shard or data redundancy. So each one will be act as a master, and each one has its own slaves. And this one, we working sharding with replication in the same time. So this is how they work with each other, and it's a go for horizontal scaling, data isolation, data access logic, sharded key selection, query complex is also management and maintaining. This is what we use sharding for, and what we use the replication for. So let's talk about the second thing, which will be the chat. So the second is unique to chat system. Chat history data is important to understand the read and write pattern. The amount of data is enormous for chat system. A previous study reveals that Facebook Messenger and WhatsApp process 60 billion messages a day. Only recent chats are accessed frequently. Users do not actually look up for all chat that much. Although very recent chat history is viewed, in most cases, users might use features that require random access of data, such as search, view your mention, jump to specific message, etc. These cases should be supported by the data access layer. So it's important to know that the read and write ratio is about 1 to 1 for the chat system. So we're going to select I guess the correct storage system for that, because we have a huge 60 billion and we have a huge volumes. As is we recommend or to use the key value store for the reason that I'm going to say. First of all, we have the key value store. What is a key value store? First, so a key value store is a typical NoSQL database that stores data as a collection of key value pairs. It is in this data model, each piece of data value is isolated with unique identifier key, allowing for efficient retrieval and storage. Key value stores are designed to be simple, fast, and highly scalable, making them suitable for various use cases, particularly when read and write operations need to be lightning fast. So it's a good, it's a quite simplicity. It's high performance, it's scalability. The schema is flexible. It have in-memory and persistent storage. We have atomic operations, data partitioning, and yeah, that's what we have. So we could use also the key value store provide a very low latency. Relational database do not handle long tail. So what is long tail? This is one of the key things actually. Um, Let me just. The long tail is a concept often used in business and economics and describe distribution patterns, um, where a significant number of items or occurrence have low frequency, making up uh, the long tail of the distribution curve. So what the hell the um, um, give me a minute. What that means? So in other words, the long tail concept in databases refers to distribution patterns where a significant portion of data consists of items with low frequency or concurrency. In other words, there are few items that are extremely popular or common, while a vast number of items are retrievably rare or infrequent. This concept is borrowed from statistics and economics, and it has been applied to various fields, including the database. So, in the chat system, you have only the last messages are being accessed a lot and accessed frequently, but the old one not accessed that much. So the relational database is not good at handling this part, and what is better than handling this part is the key value store. So also the key value store are adopted by other proven reliable chat application. For example, Facebook and Messenger and Discord, they are using Cassandra and HBase. And yeah, um, did I miss something while I'm talking? Yeah, the horizontal scale. If you wanna know what is a horizontal scale, so I guess I talked about this much, but I will just say quick. So horizontal scale, also known as scaling out, is a method of increasing capacity of a system by adding more hardware resources such as servers, storage, or network components. So, for example, let me just scroll down here. Let's say if we have this server and we wanna increase this server, so what we will do in the horizontal scaling, we'll just add more machines. So we'll just do add this, and this, and just when and just by that we are just horizontally scaling. So right now, when this only this server handling the the traffic by itself. No, that all of these server will handling the traffic, so it will be evenly, and we use a load balancer to distribute the request between all of them. So yeah, that's it for this video. I hope my description was quite good. If you like my content, make sure to subscribe to the channel and hit the notification bell so you'll never miss a video, and see you in future problems.